Good evening, everyone. How has everyone been doing in the past week?
Doing good, Jerry. How about you?
Hi, John. Glad to hear that. I'm fine.
Good.
How about James?
I'm okay.
Well, sounds interesting though.
Yeah.
So welcome to our week 4 or week 5 TA office hour. And tonight, the homework form will be due. So I will be glad to address any of the questions if you have started working on homework form and run into some questions. Hello, Tilda.
Hello.
I see more coming. So maybe this time the homework is slightly more challenging than before. So I see more students. Is it true, or did you actually find the homework to be easy?
No, not easy.
Oh no. Oh, okay. Sorry to hear about it. Yeah. So in the past week, we basically built on what we learned 2 weeks ago when doing linear regression. This time we're adding more predictors, including the square of a variable, and we need to build some dummy variables. So we have models with more than one predictors. So how about some questions? Let's jump into the question and answer section.
So, all right. So I'll start because I think I saw some people ask this question. So for for 1E, it talks about, let's see, how would weekly gross revenue change if you increase television advertisement by 2,000 in a week where you spend 3,000? So I was a little bit thrown off by this, and I looked at it from a, because it says if you increase television advertisement by 2,000, but it doesn't give you a starting point, right? It just says it increased by 2,000, and it said, and then it says where you spent 3,000 on newspaper advertisement. So what I did, instead of looking for a formula, I looked at the actual chart itself. And I was looking for an example that was similar or near to that. So I found from week 5 to 6, there's an approximately 2,000 increase in television advertisement, and then the newspaper advertisement was like 2.6, so it's close to 3. And so I just used that as an example. But yes, that's where I was.
All right. So that was James' question about 1E, where he chose to use to visually identify this effect. Did any of other students have other approaches attacking to attacking question part E in problem 1?
Multiplied it by the slope.
Okay. Could you elaborate on how you did so?
And I haven't gotten to my computer yet, but
okay. Or maybe provide some candidate answer.
Some what?
Some candidate answer. What result you have got there?
Somebody. I'm sorry. I shouldn't have unmuted because my computer's not on yet.
I'll go.
Yeah.
So for part E, maybe I'm doing this completely wrong, but right, like this is where we use dummy variables and create a first order linear kind of relationship here, right? And each portion is going to have its own slope, right? So
could you pause there? Are you talking about problem 1 in assignment 4?
Sorry, I'm talking about 2. I apologize.
Oh, I
You
see.
were saying E and I'm looking at the wrong page here. Sorry.
Oh, okay. Yeah, we were talking about problem 1, part E.
Sorry, I'm so sorry.
Yeah,
Are
we'll
you-
come back to problem 2 later.
I
For
used it.
Jerry, for 1E, I looked at it as if 1 unit is 1,000, and that's how much if we want to look at. So I looked at the slope, and the change that would occur at 1 unit is a certain amount, so 1,238. So then I said since it's being changed by 2,000, then I want it to change by 2 units. So then that's what I thought that the change would be, or the impact on the revenue would be.
Okay, excellent. So who was it though? That recommended an alternative approach?
My
Oh,
name is
Nisha.
Nisha.
Yeah.
Hello. Yeah.
Oh, great to that you're here. So wonderful. Let's discuss on this. Short answer is that Nisha's approach is the best, whereas James' approach, visually identify the effect, rarely is applied in reality in data analytics, although not professionally done, it's somewhat okay. But in professional projects, this is rarely done in this way. So let's take a look at what we meant here. In problem 1, we are working on the advertising expenditure and gross revenue of movie theaters. So, okay. Oh, right. I didn't build a plot, that's why. Okay, well, so we have built a linear regression model with 2 predictors in part B in problem 1. One predictor is the TV advertising investment, and the other is newspaper advertising expenditures. So when the question is asking about the effect on TV advertising, notice that this has nothing to do with wherever the newspaper advertising is being held. You could practice this if you change the $3,000 spent on newspaper advertising to any number that you could want. So we could change from the anchor point of 3,000 in newspaper to maybe 4,000, 5,000. You will find wherever this anchor point of newspaper expenditure is, we will still find the same effect of additionally $2,000 spent on television advertising. So this means when we use linear regression models, each of the predictors' effect is assessed when holding other predictors' values constant. So the effects are controlled for other effects from other predictors. So that's why we could ignore wherever the newspaper advertising expenditure is in part E. The reason why we don't use visually identified effect is that this may not be accurate. As you can see, if you made any plots for problem 1, the plots are surrounded are around the trend line. It's not exactly on the trend line. So that's why we use a linear regression model to find the most important relationship. And here, if we visually identify it, we introduce some human errors into it. So it'll be better to calculate the effect out of the regression equation. An regression equation has an example that we worked on in in assignment 3, where we use the intercept and coefficients from the summary output of linear regression models to build or to construct the linear to construct the regression equation. Then from the regression equation, as Nisha recommended, this 2,000 additional more dollars spent in TV advertising. As she said, it's 2 units of increase because each unit in the model is assessed as $1,000, right? So we basically put 2 as the additional amount, then times it by the coefficient of the TV advertising because we are assessing the TV advertising effect. So
Can you go over that one more time? It seems like I'm not following.
oh, okay. Which part would you need some elaboration?
When you say, I understand the bit whereby you said that you go by Nisha's way of doing it and
Okay.
look at the equation, use the equation and feed in. And when we're using the equation, are we using the y with a hat, or are we using?
So if we're using the 2E model, where we did a dummy variable and an interaction, sorry, I'm gonna lower these. We found a median, and now that's where I'm stuck. How do I utilize the equation to predict the income increase?
Oh, okay. So have you already estimated the model? You did, it seems so.
I thought so.
So where's your model estimation results?
Here we go.
Okay, yeah, you got from there. We should use this regression equation to estimate the effects in part E and part F and G in problem 2. Were you thinking about other ways?
So would I use this equation here?
Yeah.
And then I just, wait, what was the amount? 80 to 90?
Yes, that's why the question provides a hint saying that using the model we estimated in part E to address this question.
Hey, Jerry, so
Hi, James.
just wanted to add to that. So I think, the approach that we took was, taking that regression analysis, you pull up the equation, your intercept plus your income slope times whatever income X plus dummy times X plus interaction times X.
Yeah.
Right. And then you kind of use that model to kind of pull that up.
You're right. So could Michelle share your screen again where you showed us the estimated regression equation
Yes.
of part E? Oh, I see. Yeah, there might be some confusion in terms of what to do with the value of the square and the interaction and dummy, right? So let's go back there.
This one? And I don't know if this is right.
Yes, it looks fine. As long as you set up the dummy and the interactions correctly. So in this model, in cell A22, all of us could see a regression equation Michelle estimated or derived from the estimated coefficients, and it looks correct. So when we use this regression equation to estimate effects at different points of income, we simply plug in income, for example, at 80,000. I think that's the starting point, right? So first we put in 80,000 in income. Then what to do with the dummy and interaction? Notice that this dummy and interaction is built based on the median income, right? And the median income is how much? Let's see.
Is it this one, 144?
Okay, it's 144, right? So $80,000 of income is less than the median, which is $144,000. So that's why the dummy variable will take a value of 0 because it belongs to the reference level of 80,000 belongs to the low income group. And therefore, the interaction value is also 0 because dummy variable is 0. So that's how we calculate the predicted life satisfaction of a person with an income of $80,000 per year. Did I make myself
Got
clear?
it.
Mhm.
So based on that, we could calculate again for the value at 90,000. And we would do the same for part F. And I would leave it to you to find a way to correctly calculate the value of interaction and dummy variables in part F. Or part G, right? Yeah. So we follow the same rule of constructing the dummy and interaction term when we construct these variables. If we need to calculate values for additional reference levels.
Hey, Jerry.
Hi, Irene.
It's Irene. Hi. So from a math perspective, I'm following what you and Michelle were talking about, but I think maybe, so I got the same exact sort of that table that Michelle showed and then her formula, I got there, but I guess I'm still struggling. I understand how we got to the dummy. So right, 0 if it's below the median, 1 if it's not. I understand that. But what should we think of the interaction? I guess I'm a little how would we know if this was another problem, let's say, that I should be multiplying my dummy, either 0 or 1, versus my income, which is what I did in this case. That's how I did my interaction. I multiplied income and my dummy to get my interaction. But so I know that's correct based on kind of me checking my work, based on what you and Michelle were talking about. But how do I know going forward, if it's just another problem, is it always going to be multiplying, those your other independents? Is that how to think about that?
Okay. You had a very long question, but in short, it seems you were actually wondering how to interpret or understand the interaction term in a model. Am I correct?
Yeah.
So a good way to understand this is to build some scenario. Let me show this example. Okay. By sharing my screen, although I need to reconstruct the so the interaction term basically allows a different coefficient for different segment of the data. Notice the 2 broken straight lines. That's the result of adding interaction term in it with a dummy variable. So that for the low income group, the coefficient or the slope between life satisfaction and income is greater, notice that this upward trend is greater. However, for the high income group, the slope between life satisfaction and income is lower than for the low income group. So that's the reason, I mean, that's the result of adding interaction and dumbing into it. And if you, does this answer your question really well?
You know, not, I mean, it makes sense what you're saying. Like, I get it. Like at lower income, you have a steeper slope because the, you know, at that point, your satisfaction does go up when your income goes up. And at your higher income, it seems like the, your income is not as impactful, right? But I guess I'm just, maybe I'm just trying to think, like, if this was another problem, how would I think about what to do for my interaction? Would it be this? Yeah, like, so how would I get to, how would I even know what my interaction should be if this was another problem?
Oh, okay. So having an interaction is the interaction variable is always constructed by the multiplication of another two variables.
Oh, like always, like that's always how I should think about the interaction?
Yes, whenever you add one interaction, you must make sure the two variables that's associated or that's used that are used for to construct interaction is all are both included in the model. So it does not make sense if we build a model saying using only the interaction term. We must have a dummy and the original variable, that's income here, together with this interaction in the same model. I can explain using the way of writing equation to make it clear. I think so. First, this is part E of problem 2, where we need to add interaction and dummy variables into the model. And the dummy variable, as it's instructed, equals 0 for low income group and 1 when for high income group, right? So we can write two different linear regression equations out of this. So for low income, notice that for low income, this dummy is always equal to 0, right?
Right.
So as a result, this interaction is also equal to 0 because interaction is the dummy times income, right? So it's also 0. So what does it mean for our regression equation? So using what we already know for low income group, we know that this regression equation should be the satisfaction. We still have the intercept, which is
7.499 or
499. Let's do it this
50.
50. Then what to do with the dummy? So notice that we could still write this coefficient into it. However, the dummy variable is always 0 in this case. So
so that'll be 0.
Simply plug in it here. Then what to do with the income? So the income is added this way, right? So it's 0.43 times income. Then the interaction term. So the interaction, as we quoted above, it also equals to 0 because of the value of the dummy variable. And when we consider it, the coefficient of interaction is that multiplying with, sorry, I'm typing wrong. Okay, this much, with 0 again. So if we simplify it, we would throw away the effects of dummy and interaction, because their values is always 0. So we do not see the interaction and dummy variable effects for lower income, right?
Right.
This is the lower income. So what to do with higher income, high income? We know
So
that
it would be,
right? This is what how I would construct the higher income. As a result, the regression equation needs to be updated. First, we still have the same intercept to confirm it. But notice here, we also need to add the dummy variable, because now it equals to 1, right? So we replace 0 by 1.
right.
And the next step, the income effect is the same. We still have this term here, right? The effect of income for this part is still 0.43. However, for the interaction, we need to update it again, because the value of the income is 1 here, and we need to times the income. So if we simplify it, did you follow me?
I'm following.
Yeah. So if we simplify this this equation, we find that the intercept, if we reconstruct again, is different. So here the intercept is the sum of these two terms. So it'll be 41.3. Then the effect of income is also updated when we sum these two terms. So the slope of the income would be 0.07. Sorry, 0.17 times income. So notice that this is exactly what these two different lines indicate. Yeah. So notice that in the first one, the slope is 0.43, right? And this is steeper. And in the second one, the slope is 0.17. So that's why you see it as it's flatter. So when we use dummy variables, we plug in 0 and 1 into the equation. And when we have interaction terms, we also would substitute known values into it if we want to have group-specific equations. Yeah.
Okay.
So
No,
is
that
this
helps.
a very good way to understand the meaning of dummy and interactions?
Yes, it does. It does help. Thank you.
Did what I do make sense to other students? I know this might be some additional information than what we have learned in the class, but this is a good way to understand dummy and interaction. We basically plug in the representative value, for example, here, that's the dummy variable to represent low and high income. Then we could simplify the original regression equation into group-specific regression equation to help us understand the different effects for different groups.
Hi, Jerry. I have a question.
Hi, that's Luigi.
Yeah. So when we set up a dummy variable, do we always set up this interaction term, or can we just have done it with just a dummy variable with no interaction term?
Okay, excellent question. Depends. As I said, if you have if you want to have an interaction term, you also need to make sure both variables that's interacted are also included in the same model. However, if you just want to have one model that has a dummy variable, it's quite okay to have a models, for example, in our case would be for high income and low income, we include the model, include the dummy, but we do not include the interaction term. It's also possible, but the meaning of the model that you suggested here would be different than what we worked on in part E if we did not include the interaction term in here.
So it's basically kind of up to us to figure out, do we want to use an interaction term or not? Like, let's say a different example or a different real life example, we need to figure out which models would fit the best data, right?
That's a very useful way to make a judgment of whether to include interaction or not. So
Right.
as Yushi said, a typical way is to basically compare models with interaction and models without interaction to see which one fit the data better.
Because when we do the second order polynomial, if you go on the high end, the value starts to decline a lot.
Mhm.
And in our second model, over 350,000, you go, I think you go over 100 on the life satisfaction. So both models at the extreme ends wouldn't work, right?
Yeah, so if we visualize the data, let me show the plot again. We could make some preliminary judgment for whether an interaction term is needed or not. As we practiced earlier, the effect of having an interaction term is that the slope of the lines at different segments in the data are different, right? If we simply want to have a linear relationship that we find that or using some theories or previous knowledge, we know that there should not be different slope at different ranges of the data, then we do not add the interaction term. However, as you said, we can throw away this human error of subjective judgment by comparing models objectively using the goodness of fit measures like R-square and some other tests.
I got a question, and this might go against what you just said, Jerry, but I didn't professor say that the more independent variables you have, it's never going to decrease the R squared.
That's
so
true.
why not do the interaction? What do you have to lose?
Oh, right. The R square does increase whenever you add additional variables, but it's another question of whether this increase is significant or not. So when
Sorry, can you say that last sentence again? It depends. Your last sentence you said.
Yeah. So when we compare models, we of the same dependent variable but different predictors or independent variables. The more independent variables we have in the model, of course, will increase R square as what we learned so far. However, it's another question regarding whether this increase in R square from a simplified model with fewer predictors to a more complicated or complex models with more predictors is significant or not. So there are statistical tests that allows us to assess this increase in R square. So some points we find that R square does increase, maybe let's say from 0.9 to 0.91, but this 1% increase, is this significant or not? We could test it using some statistical tests that we will learn in the future.
Okay. Thank you.
Yeah. Then we could have a thought experiment here. If we build a model, as Yuichi recommended, with only income and dummy variable here, we will find that the coefficients estimated for both the dummy and income would be different than what we had in part E, where we included interaction. So including and not including interaction would change the coefficients estimated for dummy and income. For the model without interaction, we would find that the slope of both segments are the same. However, they have different intercept with the axes. That's what the plot would look like if we have a model without interaction. Because as we illustrated here, the interaction term changes the slope, whereas the dummy variable changes the intercept.
Hey, Jerry, it's Irene again.
Hi,
Can you
Irene.
scroll over to your right? So I'm looking at your scatter plot and I'm trying to, I don't think how are you, how do you get this, how are you getting the scatter plot? I guess I'm having trouble getting that when I
Can you
input.
show me what you have there?
Sorry, I deleted it. Hold on, let me.
Oh,
I was
okay.
getting it. I was getting it
So-
wrong anyway. So I was just wondering if you could help.
So notice that in this scatter plot, make sure that you select life satisfaction for the Y series and income for the X series. Do not include dummy or interaction in the X axis, because a scatter plot can only plot the relationship or coordinates of one pair of variable at a time. You cannot possibly add interaction values and dummy values into the same plot.
Oh, which is okay, because that was, I think, similar to the scatter plot I made for, what letter is that up above? Where I didn't have a dummy or an interaction yet. I just did income and life satisfaction, but with the second order polynomial. How do you make your the yellow trend line where you have the two slopes? How did you add that?
Did you see my comment in the discussion? I'm not sure whether I did this comment in this EMBA or for the full-time MBA. So I found a YouTube video that does exactly this. Let me find again so I can put in the chat room. So if you're interested, you can.
Oh yeah, that would help.
Yeah. So go ahead with other questions. I'll come back to this. So Irene was wondering how to plot on using Excel of broken line trend lines. It needs some specific technique that we add multiple data series into the same plot, basically. Let me find the video.
Okay, so is that a part of the homework for us to
No, this is not required in the homework to build broken line or the so-called piecewise linear regression plots. The plot is not needed, but it helps us to understand what the model means. As I showed earlier, having dummy changes the intercept, while whereas having an interaction changes the slope. It can be seen clearly if we add the trend line into the plot.
Yeah, definitely visually it helps. Just had no clue how to do the separation. So
Jared, you said that we wouldn't even need to know that, right?
Yeah, so.
Yeah, for the homework purpose, no, you are not required to submit any plots for the piecewise linear regression. But as I said, it does help to visualize, and maybe it helps when you do professional projects in the future.
So I didn't graph mine because I couldn't figure out to do it either. But then how come when you're running the regression analysis, you do the the dependent variable as what is it, income or whatever, or satisfaction. But then you do all 3 columns for your independent to run the regression.
Okay, yeah, excellent question. So
But-
that's the distinction between modeling and visualizing data. Am I right that James was wondering, so when plotting, we include only one predictor, but while modeling, we have 3 predictors, and you found it to be somewhat hard to understand. Am I right?
Yeah, just kind of trying to understand the concept behind that. Yeah, so when I did the regression model, you used income, dummy, and interaction as your independent, and then your life satisfaction as your dependent, which makes sense because that's what I did and how we calculate everything. But when you talked about running the actual line and plotting it, you only used life satisfaction and income. That's it. You didn't use dummy or interaction.
That's true. Let me show it again. When I said I did not use dummy and interaction in the plot, what I meant is that those black dots are plotted in this way. However, to add the trend lines that have 2 trend lines of the straight trend lines, I'm talking about the yellow straight broken lines. It does need information from the dummy and interaction terms. And that's why I included in the chat room of the how to add these trend lines. So adding the trend line does require some information regarding how we constructed the dummy and interaction terms. Wonderful. Any more questions regarding homework 4?
So in the trend line, which one are you using? Are you using the straight trend line on that, or are you using the
polynomial one?
So we're using the, I'm looking for.
That depends on which model you are referring to. If we are using part B, the polynomial, second order polynomial model, then we use the cursive or the smoother trend line that we inserted using the polynomial trend line. If we wanted to highlight the different slopes of the different income levels, then we could build additionally some plot for your information, because it's not required in this homework, for broken trend lines. So if we want to build a trend line based on part B, then we add the polynomial trend line. If we want to build build trend lines based on part E, where we have interaction and dummy variable, then we should need the technique in the chat room that I shared for using varied trend lines.
A question: after you actually get your polynomial model from part B, and CND is asking you to solve for 80 and 90, would you plug that into the equation for the polynomial?
Yes, you're right. As what we practiced in in part F and G, in the same way.
Same concept, right?
Yeah.
Okay.
So as I commented earlier, using the regression equation to estimate the effect or the predicted value is much more accurate than visually identify it. Because there are so many dots on the plot, we do not really want to pick one that's not really on the trend line, and we basically would save much more effort in visually pick an somewhat subjective judgment on which line or which segment to choose. So when we estimate the effects or the changes or the predicted values, that's where we should use the regression equation.
Correct. And does it matter which x squared or x you use to plug in, or there's a huge difference, right? It's a dumb question, maybe, but
yes. So you do need to include squares in part C and part D to in the model, because the model has these terms.
Mm-hmm.
So when we predict any values in the dependent variable, we also need to pick values for each of the predictors. So for example, in part B, if we want to predict the, for part C, right? If we want to predict the life satisfaction for a person with $80,000 income per year, then because part B's model has both income and the square of income in the predictors, so we plug in this 80,000 both in its original value and the square of 80,000 for both of these terms or independent variables included in the model.
And same with 90, right? 90
Yes.
squared and 90. Okay.
Wonderful.
Thank you.
It seems we had a great basis for part F, and I hope you can all do really well in this homework.
Thank you.
I hope so too.
Thanks, Jerry.
Thank you.
No problem.
Thank you.
Jerry.
Sure.
Thank you.
Good night.
See you next time.
Yep. Thanks,
And
Jerry.
good luck. Bye-bye.
Okay, Jerry, I'm
Hi,
thinking.
Diva.
Hi, how are you doing?
Fine. How about you?
Right. I could do better. I had a very difficult week. Actually, since last weekend, actually during that time, I had a cousin who had passed away. I was just on a trip to go help transport her body back to Africa. So I just got back yesterday and trying to catch up on with the homework.
Okay.
So,
are you fine?
Yeah, I think I should be fine. So I was just going through the homework and reading the questions, and I had only done parts 1. I had only started with question number 1. And I think the discussions that we had was good because I understood what the professor shared. I understood the class from last time and also went back to listen to the videos and so on. But it is the interpretation part that I was having a problem with, okay? So, and I think it is the language as to how to phrase it to make meaning. Like I was making up, I was still thinking that, so for that particular part, the 40% of the variation in the weekly gross revenue, okay, is captured. 40% of the variation.
I see. So I would recommend that you do not need to worry too much about, being very exact on phrasing the interpretation. It's okay if you, varies a little bit in nuances. But if you want to find out the exact way to interpret any of the statistical terms and concepts, you could always, refer to the video or using Wikipedia if you want to have exact meaning of each term.
Wikipedia, I could use Wikipedia?
It's actually used very often in statistical knowledge because
okay.
Wikipedia does include very useful information for statistical concepts.
Okay, that's very good
So
to know.
usually in the summary, in 1 or 2 sentences, it includes the definition, and from the definition, you could also have the interpretation, right? Because that's how each statistical value or statistic is defined. So we interpret it by its definition.
Okay.
So, yeah, you could do so.
Now, let me share with you because I usually go through all the questions and have an idea as part A, this is what I need to do. Part B, this is what I need to do. Part 3, this is what I need to do. So that my thoughts are sort of like flowing. Okay, so for part 1A, what I did was to run the regression model, getting that chart, the table, right? And then now part B is to run the multiple regression, whereby in this particular case, instead of
are you talking about problem 2 or 1?
Problem 1, I'm still on problem 1.
Oh, okay.
All right, problem 1, part 2, I'll then enter both the newspaper and
correct.
And the television.
TV. Yeah.
Okay. And definitely I should expect to get 2 different slopes, one for the advertising and one for the newspaper, and I should expect a change. I don't know whether it's going to be greater or lower, but I should expect a change in the R square. And in my interpretation, do I use the adjusted R square, or I just use the R square?
Sorry, I didn't catch your question.
Now, when I'm doing the interpretations, okay,
yeah,
I just keep looking at the R square without looking at the adjusted R square.
Oh, I see. Here we are talking about R square. We do not use adjusted R square yet.
Okay.
Yeah.
Then
it's clearly explained in the question. So I don't think you need to worry about additional things where the question does not include it.
Okay.
Yeah.
Now,
to make it simpler.
Okay, thank you. And then part D was thinking what I was going to do is the prediction. In that particular case, part D, I would write the equation, using the Y with a hat.
Yeah, that's what we practiced when I demonstrated using screen share how to derive a regression equation out of the estimated summary output table.
So now in this particular case, because it says what weekly gross revenue would predict if 8,000 is spent on television advertising and 2,000. So in other words, in that particular case, I just plug in those amounts, right, in the equation.
Yeah, that's exactly what we did in our practice. So you could recall what we did when you work on this question.
Right.
Yeah.
Okay. Then in problem 2, the first thing is to plot a scatter plot, right? And then after plotting the scatter plot, I go on the axis and look for and ask for a trend line, right?
Yeah, I don't think we really need to add any trend line for the homework questions though.
Okay.
But if you're interested, you could add additional practice to yourself if you want to add the trend lines onto the plot. But it's not required.
Okay, and then I would definitely do a regression on a multiple regression model. But in this particular case, I'm looking at 2 variables.
Yeah.
Okay. And then
well, let's know what's cut. So I didn't hear what you said.
sorry,
Oh, I see you're back.
it is
The voice was cut, so
I'm
I
sorry.
didn't follow. But yeah, so far so good. It seems you
Right.
have a very clear mind of what each question is asking for.
Right.
So yeah, no need to worry too much.
Okay, and then part E would be, that is when I would do my models. I'll first calculate the dummies. First calculate the median and find the median using Excel for those different, for the income, median for the income, and differentiate the 2 where one is 0 and the other one is 1. And then that is the part where I would have to go back to my notes to
so the core of working on part E is make sure that you construct the dummy and interaction terms correctly. And this is well explained in one of the videos. Yeah, you did really well on how to construct the dummy, and the interaction is simply the income times the dummy variable. So it's nothing too complex.
Okay. All right. I think I do understand this, but one thing I wanted to say to you is, remember that homework, the first homework assignment?
Which one?
The one that I emailed to you late because I hadn't done it as a PDF and so on. I think that was homework assignment 1. I think homework assignment 2.
Okay. What about it?
Right. There was some, when I was emailing it to you, attaching them as an email, there was some as paper, there's some work that I did not include because, for example, you may have, I just wanted to share this with you, that you may have noticed that maybe one question I had answered like A and B was not there. It was because B was now on a different page. And when I was when I was trying to attach it, to attach the assignments, that is something that, there were some pages that I missed as part of the homework assignment. You understand what I mean?
Okay.
So in other words,
did you mean that you had some points detected because of missing some answers?
Yes.
Okay.
That was the whole point, because what happened is I would save, it was not easy for me to fit everything on one single page. Say like, you've got the data itself, you've got all your calculations, you've got the plot, you've got everything all on that one page, so that I save that and as a PDF. So I was finding that some of those assignments, some of the pages were on a different page.
Oh, okay, I see. Well, thank you for sharing the story. I would need you to contact the TA who does grading. His name is Sally, because I didn't do grading for the assignment, so I had no clue what you were talking about.
Okay.
But it doesn't seem to be too problematic, but it sounds like you might have produced your reports in Excel, but we need to use Word here. You never submit Excel files or sheets. That's probably the reason you had some part that you worked on but was not included in the exported version.
Right.
That's my guess. But if you want to request a regrade, you need to find Sally. His email is on the front page on Canvas, and just tell him, which of this homework you had questions about on the grades and what you would like him to do on the homework. But this does not guarantee a regrade. He may, decline or accept it due to different reasons.
Right.
Yeah, but he manages the grading, so I cannot really help you at this point, except for pointing you to him. Yeah.
Right. But thank you for, because I remember speaking to you and you said email the assignment to me, remember?
Oh, I did. Okay.
Yes. I think probably that was did you ever pass it on to him or what? Because you remember when it was right after the assignment and you said that, okay, email it to me. And I emailed the assignment to you. I didn't email it to him because I was like, you said it has to be as a PDF. And I said, okay. So you said, okay, send it to me by email. So I immediately went in and emailed it to you.
I see. Oh, well, I was just looking through my emails. I did forward your email to Sally, the TA that's grading. So
okay.
This looks like homework 2.
Right, that was homework 2.
So if you had questions regarding the grade, you could simply follow up on the email because I copied to you also.
You did?
Yeah, of course.
Okay.
And because you raised a question, but I was not a person to grade it, so I forwarded it to the TA that does grading.
Okay. All right. Okay.
Yeah. So let me put in a comment. That's the, that's the email of the TA.
Okay.
So I did forward your email submission to him.
Okay.
Yeah. Well, sounds great. I'm sorry for your recent family issues, and I hope everything would be going better in the future.
I'm hoping, yeah.
So did you mean that you went to Africa in the past week?
No, I didn't. What happened, she was in Dallas. Actually, she was so close to me that my being here in this country was originated from her because she came in 1982. So she was very close to me.